Hey guys, Mr. Middleton here. Today we're going to talk about graphing exponential functions. At the end of this video you should be able to graph exponential functions by either making a table of values or accurately using and understanding the shortcut. Okay, so how do we graph this function, y equals x squared minus 5? Remember when we did this in our functions chapter, we made a table of values and then plotted the points. Okay, and so just to review in here, we had x and y. We chose these values, -2, -1, 0, 1, 2. Okay, and then we plugged them in and saw what we got. So we got -2 squared, which is 4. 4 minus 5 was -1. -1 squared, which is 1. 1 minus 5 was -4. 0 squared, 0. 0 minus 5 is -5. And then if you remember, we actually had some symmetry there. So we were able to shortcut that. Or we could plug it in. 1 squared is 1, minus 5 is -4. 2 squared is 4, minus 5 is -1. And then from there, remember all these are coordinates, so we were just able to plot these points: -2, -1, -1, -4, 0, -5, 1, -4, 2, -1. And we had a quadratic, so it looks to be a parabola, like a U-shaped curve, right? Alright, so from there, this is enough information. Our equation is enough information for us to be able to graph the function. And we're going to do that same thing with graphing exponential functions. Okay, and I'll show you a shortcut later in those, but you must understand why the shortcut works before you use it. Okay, a table of values will always work. So, looking at our first function, we have y equals 4 times 2 to the x. We're going to graph this. We want to make a table. I'll do it to the right side here. Okay, and I'll just choose the same numbers there. Okay, so I'm going to choose for x. Remember, x is our independent variable. We get to choose it. Independent. Okay, and so I'm just going to choose these numbers. They're nice, they're low, they're easy to do without a whole lot of calculator work. Okay, I'll start from the bottom up. Why not? Okay, so what we're doing is we're plugging these values in. I'll start from the top, I guess. We're plugging these values in, and so I'm going to plug -2 in for x. So I'll do 4 times 2 to the -2. That's what y equals. Now remember that with these negative exponents, and this is why this is in this chapter, with these negative exponents, remember that we can simplify this, and now instead of saying 4 times 2 to the -2, we actually have 4 over 2 squared. Well, what's 2 squared? It's 4. So we actually have 4 divided by 4, which equals 1. So when x is -2, y is 1. And we can do the same thing with all these values. So again, we'll do the same thing here. 4 times 2 to the -1, which is really 4 over 2. Okay, and that is 2. Same thing, 4 times 2 to the 0. Remember, anything to the 0 power is 1, so we have 4 times 1 here, which is just 4. I'll do the same thing here, 4 times 2 to the 1. And now 2 to the 1 is just 2, so 4 times 2, which is 8. And then last we have, can we see this still? Yeah, getting close to the edge. Okay, so last thing here we have 4 times 2 squared. 2 squared is 4, so we have 4 times 4, which is 16. Okay, and so now that's how we populated our table of values. And remember, all these give us coordinates. So we have -2, 1. So our first coordinate. We have -1, 2. We have 0, 4. We have 1, 8. And we'd have 2, 16. It's all the way up here. And our exponential function will look like this kind of curve. Okay, and each time it's going to curve a little bit faster. Okay, increasing exponentially. Okay. Okay. Hopefully you notice, because of the b value, that this is a growth function, and so you see it growing as it goes. We'll do the same thing here now with this, the next function. Have x, y. Maybe I'll make that table a little bit smaller so I can have a little bit more work room. Okay. So using the same values here, just keeping it simple. Now remember here in this case, because I'm going to plug this in, I have y equals 9 times 1/3 to the negative 2. Remember now that we have this negative 2, what's going to happen is I distribute that to both of these, and that will actually make this 9 times, I'm going to flip this. It'll be 3 squared. 9 times 3 squared, so 9 times 9, which is 81. Okay, and that's obviously going to be too big for us to place on this graph, but that's the value that it would be. Okay, I'll do the same thing with 9 times 1/3 to the negative 1. Now that'll be 9 times 3, because we're flipping that again, which would be 27. 9 times 1/3 to the 0, so 9 times 1, which is 9. 9 times 1/3 to the 1, so that's just 9 times 1/3, which is 3. Okay, I'll do that here. 9 times 1/3 squared. Okay, and so now that will be 9 times 1/9, which is 1. Okay, and so again we have our table filled out, table of values. Now we're going to plot our points. Again, negative 2, 81 is way off the graph. Negative 1, 27 is off the graph. We can start at 0, 9. We go to 1, 3. And then we go to 2. Oops, that's not 1, that's half. We go to 1, 3. And then we go to 2, 1. Okay, and so now you kind of see this curve coming down. Okay? Now notice here, our value here is less than 1, and so we can tell that that's a decay function, and you see it decaying. Okay, the opposite of growth. Growth rising, decaying, getting smaller. All right, continue with me to the back, where we'll talk about shortcut. Okay, there's 2 steps to our shortcut in this evaluating A and B. So the A value is the y-intercept. You'll notice in our tables on the front that when x was 0, we just had the number, our A value was our y-intercept. Okay? And the B value tells you what to multiply by as you move to the right, as your number gets bigger. Multiply by as you move right. Okay? And as you move left, this B value tells you what to divide by. Okay? So let's look at these two. We'll look at one of them with the shortcut, and then I'll let you finish number 2 with the shortcut. Okay? So, shortcut here for this problem, keep it in screen as we go through it. The A value tells us our y-intercept, so for number 1, our A value here is 3. Our y-intercept will be 3. The B value tells us what to multiply by as we go to the right. So, as we go to the right 1, I know I'm going to multiply by 3. So, 3 times 3 is 9. Okay? If I wanted to move left from here, I'd say, okay, I'm going to move left, so instead of multiplying, I'm going to divide. So I'm going to divide by 3. 3 divided by 3 is 1. Okay? And if I could do that, I could do that again and move left and divide 1 by 3, and that will give me 1/3, which I'll say is somewhere right here. Okay? And you'll notice again, hey, this B value is greater than 1, so it's a growth function. That should help you out to make sure that you're kind of on pace a little bit. Okay? So this A value is the y-intercept. This B value as our shortcut tells us what to multiply by as our x gets bigger, and what to divide by as our x gets smaller. So try that out for number 2 for me. Bring that in tomorrow. Okay? See ya.